Good morning, good afternoon, and good evening. Thank you to everyone for taking the time out of your busy day to join us for a very special web event. I would now like to pass the floor to our presenter today, Robert Ferrullo, a senior technical marketing engineer with Mojo Network. Robert comes to us with over 20 years of experience in the networking industry, nearly a decade in Wi-Fi, and 15 years in performance testing. Today, we kick off the first in a three-part series around campus networking. In this first session, Robert will be taking you through design best practices for campus 802.11 AC Wave 2. Without any further ado, I'll pass it to Robert.
All right, Erica, thank you very much for that introduction and welcome all. We got a lot to get through here, so I'm going to move at a pretty fast clip, and we'll start with the agenda.
Okay, great. We'll get started here again. I lost, for some reason, my phone just cut off, so I'm using VoIP now. Hopefully we'll be okay. Keep going. All right, so yes, the challenge, and we're going to be focusing more on the, for us, we'll focus on capacity as the main challenge. Of course, there are other challenges too, like security and so on, and onboarding, but today we'll focus on design and designing for capacity. We'll present a simplified wireless LAN capacity planning methodology. We'll quickly review Wave 2, in the benefits, take a quick look at the 120, and then a little bit about the Mojo planner, or AP placement plan and channel planning. And we'll look at a campus use case, and then we'll go through the summary, and we'll just touch on the upcoming webinars, and then we'll have Q&A. All right, so the challenge. Now, in my opinion, it's maybe not the most difficult challenge when trying to design a wireless network, but it's certainly up there. I would say it's up there with security, and then also maybe troubleshooting is also a big challenge, and making sure that you have, all your clients are operating and everything's working well all the time. That's a big challenge. This particular challenge, it involves a little bit of that, but really it's about, having enough capacity. So in order to make sure that you have enough capacity so that you can have all of your applications on all of your devices work anytime, anywhere, that's quite a challenge. And I'm sure most of you know that you've been in this space for a while, how daunting that challenge can be at times, especially with all of the additional clients that people are bringing on board or bringing on their person. And then if you get into dormitories, there's a lot of devices in the dorm rooms, and then you have high density areas and so on. So not only are there more devices showing up, that rate is climbing and climbing. And there's, of course, there are a lot of reports out there to show the astronomical, growth rate of all the different clients as we look into, 2020. But also the bit rate of the application. So video is one of the main drivers, and video bit rates are very, very high and getting higher, especially when we start seeing 4K show up on devices. And also BYOD, you never know what folks are going to bring in. So there's not, like in the old days, when you would design networks, Ethernet networks, you pretty much, you could test all the devices that were going to be sanctioned, so to speak, in that environment. But these days with BYOD, you never know what's going to show up. So you don't have control over the devices or the drivers that the devices are using, and so on. And plus, this is all unlicensed spectrum, so it's even more challenging than a wired network, of course, because you don't have control over what's happening over the air. You have to react to it. You have to be able to respond, react to it. Okay, a simplified wireless LAN capacity planning. How we do it. Of course, you can use Mojo Planner or other planning tools, and we'll talk about that later on. But really what I like to do is to recommend that you design for a specific use case. And to do that, you first have to discover what types of clients are being used, what applications are being used, and what are the usage patterns. Clients, it's really important to know whether you're working with 1x1 clients or 3x3 clients, because 1x1 clients, we're talking Wave 1x1 clients, they're going to have basically, if you had a network with all 1x1 clients, Wave 1, versus a network where you had all 3x3 clients, your network would have 1/3 the capacity if they were all 1x1 clients, as compared to a network with 3x3 clients, assuming that the APs were 3x3. Multi-use MIMO is changing that. But anyways, you need to know which clients you're working with. And then also building, what type of building is it? Is a building with a lot of attenuation in the walls, or less attenuation, or wide open office spaces? So want to characterize, basically the environment. Also the RF environment. Do you have, do you have interferers? Do you have a lot of Wi-Fi interference? Do you have non-Wi-Fi interference? Spectrum availability. What region are you in? Do you have access to all the DFS channels, or just some of the DFS channels, or perhaps none of the DFS channels? And then finally, we talk about a use case. So a use case can be defined as like the number of devices, plus the types of devices, the applications in use, the usage patterns. And here we're really concerned about the usage pattern. We're looking for worst case scenario, because we want to design for that worst case scenario, because remember, we want obviously all devices to work all the time, anywhere. So we're looking for worst case scenario, and for a given area, because with planners, and whether it's a Mojo planner or like Ekahau, they're going to do a plan for a whole floor or a building, but really use cases are unique to a particular area of the building, like for instance a conference room, or even a classroom. All right, let's see, Wave 2 clients. A lot of folks are really concerned, we can put Wave 2 APs in there, but what about Wave 2 clients? Well, actually, there are a lot of Wave 2 clients. What you see here in the blue on the right is some Wave 2 clients, 1x1, and then some 2x2. And that's just a small subset of clients that are available out there. So there are plenty of Wave 2 clients available. We actually, in our lab, we're testing some Acers. We have some Google Nexus 5Xs, and we have some OnePlus 2s. And so there are plenty. We're going to get more. There are lots of Wave 2 clients, so I wouldn't worry about having Wave 2 clients. Now, you can't necessarily control what your students or people are going to bring to the campus, but the refresh cycle, especially for handhelds, it's pretty fast turnover. So we'll see a lot of Wave 2 a year from now. The percentages are going to be pretty good, I think, in a lot of environments, certainly for the handhelds. A lot of folks ask about, how do I know if I have a multi-user MIMO capable client? And some systems can tell you. Our system has the ability to tell you if it's a multi-user MIMO beamforming capable. So you could use the system to do that. It would be in the dashboard, one of the dashboards. But the other way to do it is if you just do a packet capture of a client that's doing an association. So you start your sniffer, get a client to associate, and then you want to drill down on the association request, and that's what we have here, the one that's highlighted. It's an association request from a OnePlus. So excuse me, this is, I can't remember actually what I was sniffing there. It could have been the Acer, I think it's the Acer F15 series. And if you look down into the VHT capabilities info, and you're specifically looking for MU-MIMO beamforming capable supported, which is a one that says that it is supported. So that's how you can be sure if the client's capable of MU-MIMO. It's a Wave 2 client capable of MU-MIMO. Just a quick check. All right, a little bit about applications, because this is all part of the discovery process, right? To try to find out what kind of, what are the requirements. And here we see a list of different applications and the bit rates. And you can see, for instance, video streaming, 720p, which is fairly common. A lot of video is being streamed at 720p, and you get that anywhere from 3 to 5 megabits. It can be a little less, a little bit more, depending upon the video. It's how much action is. If it's if it's a lecture, obviously not much motion, not much different changing going on, so it's going to be less. But if it's a feature film, especially an action film, it can get up closer to 5, even 6 megabits per second. 1080p, then you get up to higher, that's 8 to 12, and with 4K, you're looking at 1825. So now people probably won't stream 4K to their devices, but maybe that would be more for like a monitor or a projector, and one in a given area. Let's see. There's a video game, I have it highlighted in blue because that's one where we recommend that if you don't know, and this one I haven't characterized that. So there you'd want to get a sniffer or use your system, your wireless LAN system, to benchmark it or to monitor it and see what the bit rate is. Or you could do it, look at a packet capture tool to characterize that. 5 gigahertz. Wow. One of the most controversial topics you have today in Wi-Fi, and if you go on Twitter, and follow guys in the space, follow people in the space, you'll hear them debating whether or not to use 80 megahertz. Like never use 80 megahertz. Or well, I don't hear anyone saying always use 80 megahertz, but I certainly hear people saying never use 80 megahertz. I just want to point something out. Here we have the pink channels, or the channels that are highlighted in pink, rather. That's spectrum that has been proposed by the FCC, but not yet available. And the green and the gray, that's what's available, and the yellow. The yellow was recently made available again. It was for Doppler weather radar, and it was not usable for Wi-Fi for some time, but now it's back in play. RAP support the yellow and the green and the gray. Nobody supports the red yet because it's not been made available to, well, nobody in Wi-Fi uses the red, the pink rather, yet. But anyway, so we have plenty of spectrum if you're using DFS. Now, if you're not using DFS at all, then you wouldn't want to use 80 megahertz channels. But if you have DFS, most likely, if you can't use DFS, by the way, in a given area, most likely, it's just one or two channels that you're not going to be able to use. It's not like you would not be able to use any DFS. So you would just take those channels out of your candidate list if it's determined that you're having radar events on those specific channels. So in summary, if we look at in US anyways, we have 2.4 gigahertz is of course 3 channels in the US, for instance 1611. And then if we look at 5 gigahertz without DFS, we're looking at 20 megahertz channels, and with DFS 25, and then with the proposed 37. So even without the proposed, and if we look at the number of channels, 80 megahertz channels, we're looking at 6. Now, we've been designing wireless networks for many years with 3 channels, 320 megahertz channels. We can definitely design networks with 6 80 megahertz channels, and they'll work quite well. Yes, sideband interference is more of an issue, and signal-to-noise ratio needs to be higher for the higher data rates with the wider channels. But still, that's plenty to work with there. So I definitely recommend, if you can use DFS channels, at least some DFS channels, to go with the wider channel, because that's where you get your most bang for your buck. Certainly, when you go from 11N to 11AC, is by using the wider channels. And then if you go out here and you look, look at the ratio. We're going to be talking about designing networks for 5 gigahertz, and the main reason being is because if you look at that ratio, it's about 8-to-1 ratio, a little bit more currently with DFS channels. So the 2.4 spectrum is it's not really that significant with regards to the 5 gigahertz. So we really design networks around 5 gigahertz, knowing that there'll be a little bit of a spectrum available in 2.4. And if you go out further with the proposed, now it's going to be about a 12-to-1 ratio. So, 2.4, we're not saying don't use 2.4. There are a lot of devices out there still that, are 2.4 only. Yes, you want to provision your network with 2.4 pervasively. It's just that, the capacity in 2.4 is going to be much less than in 5 gigahertz. So we design around 5 gigahertz, but we provision pervasively for 2.4 as well. Okay, now here, this is a reference. We put up some, because when we get into channel capacity planning, we need to think about the capacity of a radio. And what we're doing here is we start with the max data rates. These are not throughput rates. These are just max PHY rates or max data rates for different types of clients with different channel widths. And we'll focus mostly on the 80 megahertz. So here, and most of you know this already, for a single spatial stream, you're looking at 433. And 2 spatial stream like a MacBook Air, 867, and a 3 spatial stream like a MacBook Pro, 1.33 gig. So that would be the data rate that you could expect to connect that if you had the AP and the client close to each other on a clean channel. You'd expect them to operate at the max data rate. Now, when you start looking at throughput, right, you already drop down to about 60%. You can do better. I've had some clients go as much as 75% of max data rate, and that is to say, 75% of that of the max data rate of the 433 it turned out to be, we can get that in TCP throughput. For instance, with a single spatial stream 1+2 client connecting at a 433 megabit PHY rate data rate, we're able to consistently get with the C120 320 megabits per second. That's awesome. That's a 75% of max data rate, which is not normal. Normally, we say for a single client, the estimated max throughput would be somewhere around 60%. And from there, it gets worse with Wi-Fi, for all Wi-Fi, because, and really we're talking Wave 1 or 11N or legacy Wi-Fi, because you have contention loss. And so if we look at now, say upwards of 15 clients, and we'll use that, we'll use the 2 spatial stream clients. And now we're looking at, if we go back, we had 520 for a single, like MacBook Air, which would be a decent result for a MacBook Air. And then when we have, say, if we had 15 MacBook Airs, the aggregate shared throughput for those devices would be around 303 megabits per second. It could be better, it could be worse, depending upon a lot of things. The conditions of the air. Here, we're assuming that the channel is a nice, clean 80 megahertz channel. We don't have any non-Wi-Fi interference or any Wi-Fi interference. And we're saying we're going to get about a 5% loss due to contention, and then also we're going to get some loss due to rate adaptation, signal degradation, because these clients are not going to be all sitting next to the AP. They're going to be spread around like in a real use case. Multi-user MIMO is not factored in for any of these tables. By the way, these tables were developed over many years of doing legacy testing, 11N testing, and 11AC testing, and it was competitive testing, so it's not just one vendor, and we're talking enterprise class access points. And the way that these tables were derived was doing single client tests, 5 client tests, 10 client tests, 15, 20, all the way up to 60 client throughput tests, with the clients near the APs and then the clients spread around. So if you do all that testing, you start to see patterns, and those patterns will help you give some guidelines, and that's what we have in these tables here. Here's the next slide. When we go up to now 30 clients, we see that for a single spatial stream client, the aggregate throughput for 30 single spatial stream clients, now they're going to share that 139 megabits. And so you see we have more loss due to contention because the number of clients is greater. Again, we'll still keep the loss of 20% constant for single strength and rate adaptation. And again, multi-user MIMO is not factored in. Now, if we go up and add more clients, oops, I skipped one. For high density, up to 45 clients. Now those clients, 45 clients, will be sharing 117. So you see a lot of loss due to contention. And that's where you get diminishing returns with Wi-Fi. So when you see vendors say we support up to 250 clients per radio, well, yeah, but those clients better not be trying to do something all at once, because it would if you try to have 250 clients actually actively transmitting traffic upstream or downstream, it would be horrible. A lot of clients would just completely get starved. And that's not just for one vendor, that'd be for any vendor, because that's just the way Wi-Fi works. So be careful when you have a vendor saying that they want to support up to 250 clients per radio. And if we continue on then to very high density, up to 60 clients per radio, now we're looking at sharing 87 megabits per second. So you see, when you design networks, if you want to start connecting like up to 60 clients per radio, just be aware that with Wave 1, this is pre-multi-user MIMO, you're going to have a lot of contention, and you're going to get a lot of loss due to contention. And so here's, before we move on to the next, we'll just summarize, follow with this little 2-step process when we're going to try to do some channel capacity planning. Back of the napkin type calculations, where you take the application bit rate, like the highest bit rate application. Again, we're designing for worst case scenario, or the per client service level agreement in throughput, and you divide that by the channel capacity times 100, and we'll get per device airtime. And then once we have the per device airtime in step 2, we just multiply that times the number of active devices, not necessarily the number of devices that are connected to the radio, but the ones that are going to be active concurrently. And that'll give you your total airtime required, or the number of channels, unique channels. Can't reuse the same channels in the same space. That wouldn't buy you anything. And so unique channels and radios required. And that's how we come up with the estimation for channel capacity requirements. So here's some of the, in summary, some recommendations. You say you design for wireless and capacity. The days of designing for coverage, there are probably still some use cases for coverage. There are, but mostly we're designing for capacity these days. We design around 5 gigahertz. We talked about how few channels there are in 2.4 anyways. We're going to focus design on specific use cases. So you can design for a whole building or a whole floor of a building, but Are you going to have uniform requirements throughout that whole floor? Maybe, maybe not. It depends on the the type of building or what's going on in that on that floor of the building. And we're going to design for the most demanding application. You want to use the current wireless LAN to determine the number of devices. That's where you can just kind of do some trend analysis of the number of devices and also the types of devices. And you can use the current wireless LAN or a packet capture tool to determine application bit rates if you're unsure. You want to right size the AP for the use case, or the use case, uses case, that's not right, I got a typo there, use case. You want to use DFS channels. Again, if you can't use a DFS channel, you can remove that channel from the candidate list. And people say, well, I don't think all my devices support DFS. Well, most devices do these days. Older ones, they won't, but you're going to be provisioned for 2.4 anyways. And so if there's what would be a coverage hole for a device because that device doesn't support 5 gigahertz, at least not the 5 gigahertz channel there, the DFS channel, it wouldn't see that channel, then it would use the 2.4 gigahertz. And also use 80 megahertz channels, again, being repetitive, but yeah. And use channel capacity planning tools or predictive planning tools like Mojo Planner to estimate the number of APs required. That'll give you, just a ballpark to start getting a rough idea of how many APs you're going to need for a whole, for a whole building or series of buildings. All right, review of the benefits, just briefly. So you see wave 1 and wave 2, and what's highlighted in blue really are the big benefits that you're going to see for wave 2. Channel width with wave 2, we can get from 80 plus 80, 2 non-contiguous 80 megahertz channels can be bonded to form a 160 megahertz channel or a contiguous 160 megahertz channel. Here, you're gonna right away you'll double the throughput capacity of an 80 megahertz. However, we don't have a lot of spectrum, so I'm not right now. There are only 3 160 megahertz channels available, and without the additional spectrum, and even with the additional spectrum, there'll only be 4. So designing a network for pervasive 160 megahertz is really not recommended at this point. Using 160 where it makes sense, maybe an area that's low density but a real high throughput area, it's out, somewhere isolated, and you just really need the throughput, but it's not high density, not a lot of devices. Then you may want to go 160, but those would be rare use cases, at least for now. As more spectrum is made available, then buying APs that support 160 megahertz will future-proof your network. Okay, so moving down, QAM is the same, quadro amplitude modulation encoding. There's no change there. Spatial streams, we see with the wave 2 APs up to 4 spatial streams right now. The spec says up to 8. You're really not seeing those kind of APs marketed right now up to 8 spatial streams. They would have to have a lot of antennas, well, at least 8 antennas on the 5 gigahertz. So that would be a pretty wild AP. Be large, obviously. Explicit beamforming, that's something that's required for wave 2 APs. Multi-user MIMO, again, multi-user MIMO is where we're going to be able to talk to up to 4 clients simultaneously. So remember we talked about contention. Well, multi-user MIMO is really going to mitigate, and more than mitigate, the effects of contention. If you just mitigated the effects of contention, then you wouldn't see the contention loss. And so you would get aggregate throughput comparable to the single client throughput or something like that. But what we're seeing is actually you get more than the single client throughput. You can get 2x the throughput of a single client throughput, because it's going to be the first time that wireless is switch-like. So we're going to be able to talk to multiple clients at one time. So that's one of the main drivers behind opting for a multi-user wave 2 rather. Frame aggregation, no change there. Band supported, no change. Forward overcorrection, no change. And then dynamic channel width. Not all wave 1 APs supported dynamic channel width. I'm hopeful, and I don't know that for sure that all wave 2 APs support dynamic channel width. The C120 certainly does. That's where if you configure an 80 megahertz channel, but only 20 megahertz, the primary 20 megahertz is available, well, the AP will then transmit on the primary 20 megahertz. Or if only the primary 40 megahertz is available, then the AP will transmit on the primary 40 megahertz. So it's dynamic. If the whole 80 megahertz channel is available, then it will do 80 megahertz. And it can do it packet by packet. So it's not all or nothing. It's not like, oh, I need the whole 80 megahertz, otherwise I have to defer. No, that's not how it works. So dynamic channel width it allows you to configure 80 megahertz without worrying that you're going to hurt, be shooting yourself in the foot by doing that. All right, the 120 talked about a little bit already. It's dual radio, of course, and it's up to 800 megabits PHY rate, data rate. We're not talking throughput, we're talking PHY rate, right? And then 1.7 gigabits on the 5 gigahertz radio, PHY rate again. And it supports 4x4 multis and MIMO. Some of the Wave 2 APs that were released previously by the competitors, they didn't support up to 4 spatial streams. They only up to 3 multis and MIMO. So the spec has you allowing you up to 4, and the 120 supports up to 4. And a number of APs don't have support. The Wave 2 APs from competitors don't have support for 160 megahertz or 80 plus 80. And again, it's really about future-proofing your network. We have support for that on the C120, so it's something to consider. 2 gig Ethernet ports and so on, and fully operational with the AT PoE, but it will also operate with AF PoE with reduced functionality, like the USB port won't be lit up, neither will the second Ethernet port, and we'll drop down to I think it's 1 spatial stream instead of 4 spatial streams on the 2.4. And reduce the number of spatial streams on the 5 gig. So if you have PoE AF or regular standard PoE, you could install these. The AP would certainly work with some reduced functionality. And that's not unique to the Mojo 120. That's basically because all Wave 2 APs really need PoE plus to operate at full functionality. All right, AP placement plan. Just a little bit about the Mojo Planner. It's a tool. It's free for our customers, and it's something that it's good to get some floor plans with some AP placement for to get started and to get an idea of how many APs you're going to need. So when you start this, you have the workflow choice. You can either go for coverage, which there where you're just looking for square footage, or you can go for capacity. If you choose the workflow for capacity, you're going to be asked a number of things. For instance, you'll be asked for about the the types of devices. It can be mostly smartphones or tablets or all laptops and or a mixture of laptops and tablets. And it will ask you if it's legacy. Most of the the clients are using legacy, or are they mostly 11AC? The number of active users, the expected throughput per user, or the SLA. And here, that's a 5 meg SLA there, or 500 kilobits. And then also voice, if you have voice, and how many voice calls per AP and so on. You do that, and basically you'll come up with a placement plan for you, an AP placement and channel plan for you. And it's all automatic. And so it really simplifies things. Now, this assumes that we have uniformity here, because it was designed, this plan was for this floor. But what if for instance, that in this particular area, you have high density? Well, then that's where you would, you could go and do a separate use case, the back end of the napkin one that we talked about, where you could do that for here. So maybe you need 2 APs here or 3 APs here. So you have both of the tools at your disposal, the manual method and then the planner. Just quickly about attenuation. When you do these kind of predictive site surveys, you have to obviously take the time to know what type of attenuation you have, and there are already attenuation levels set for the types of it's pre-configured in the planner, but just as a reference, I thought I'd put this up, and so you could have that, and you may at times need to do some measurement to find out what attenuation you have. Some kind of obstruction, you don't know what it is, what the type of attenuation, and you have a lot of this particular type of obstruction, and you want to put that and represent that in the planner, where you could do a manual measurement here, and it shows the methodology of doing the free space measurement, and then you do the measurement again with the obstruction behind the obstruction, and that's how you can get the attenuation loss, and then you would put that in the planner so that your plan would be more accurate. Now here, of course, we have our auto channel, and this, or like RRM, from other vendors that you may be familiar with. but not, if you look at auto channel, and this is when I've done a lot of multi-AP competitive testing over the years, I have never seen auto channel come up with a better channel plan than a manual channel plan. All over the years, the best channel plan that I've ever seen was one that we manually configured. So I thought I'd share, just as a reference, a 40 megahertz channel plan. That's if you can't use any DFS for some reason, that's using 40 megahertz channels as for reference. And then if you do use DFS channels and you have all 6 available, here's just a reference channel plan for if you were going to do a manual 80 megahertz channel plan. And let's see, moving on. Just some max client recommendations in choosing the right AP as part of the design process. We have, these are all our 11AC APs that we currently have available. And I won't go through all of them, but what I did was I just basically came up with some max active client recommendations. That's not to say there can't be more clients associated. Certainly they can. You could have 120 clients associated per radio. But as far as if you're going to design, you should design for these maximum numbers of active clients, that is. And then with the ratio broken down 25 to 15 for the 5 gig radio and the 2.4 gig radio. And these are just guidelines. You could actually change the ratio depending upon what type of applications or what type of SSIDs you have on the 2 radios. All right, so just some summarize for the placement plan, channel plan recommendations. Input the client types and the quantity. We saw that when we were doing the capacity workflow. And input the applications. Again, that's part of the capacity workflow. And design for capacity. And use high quality floor plans. Be very precise when scaling. A lot of us have done the 3 feet for a door, and you want to be more precise than that when you do the scaling for the floor plan. And just consider RF leakage. You probably want to measure the RF leakage between floors, because that'll determine whether or not you want to do a staggered from floor to floor AP placement plan, or you want to put the APs right on top of each other. So not every floor is the same, plan, so to speak, which is usually not recommended unless there's hardly any leakage or no leakage between the floors. All right, moving on to the classroom use. We're going to look at classrooms. So I'm going to do a simple manual design, back of the napkin type of design, and then we'll look at finish up with the plan, the AP placement plan. So here we have 30 devices active concurrently in a classroom, per classroom that is. They're going to be Wave 2 devices, and we want to deliver a 5 meg SLA to each device. So we start with doing that step 1, right? Where we're going to take the application bitrate or the SLA and divide it by the channel capacity times 100 to get the per device airtime. And we have 208 up here in the capacity. Now, how did I get that? Well, if you remember, I had something highlighted in the back, earlier on in the presentation, and that was 139 megabits. Now, that was Wave 1 with 80 megahertz for single stream devices with a moderate channel capacity. So we estimated that the aggregate available throughput would be 139 megabits. Now, conservatively, I'm saying that if these are Wave 2 devices, we're going to see, at a minimum gain of 50%, gain in capacity over the 139. Some tests have shown it's over 2x, right? So, but we're not saying that. We're just going to say a modest, 50% gain. And we'll design that way to be, conservative. Again, these have to be Wave 2 devices, and the AP has to be a Wave 2 AP. And when we do that simple math, we come up with each device taking up 2.4% of the airtime. That's 5 meg divided by the aggregate times 100. So that comes up to 2.4 per device. Now, if we then go to step 2 and multiply that times the number of devices, 30 devices in a given classroom active. There can be more devices in there. There may be 60, but we're saying that 30 are going to be active concurrently. And we're going to say that then that's going to be a total of 72% of total airtime. So we round that up, 1 AP. Now, so we have that 1 AP with capacity to spare, but certainly 1 AP would cover that use case. So we have 1 AP per classroom in this scenario. And if we take that out to so we just show then we have 1 AP per classroom. And again, I proposed a manual channel plan. You could let auto channel do this for you. But I'm not saying don't use auto channel. Certainly, use auto channel, but I just proposed here a manual plan, and I'm trying to create as much separation before reusing those channels. For instance, they have the 36E, that would be 36, 40, 44, and 48 because it's a 40 megahertz channel, and we reuse that twice. And in fact, I think we reuse, in this example, we reuse each channel for this wing of the school. We reuse each channel one time. All right, and let me go to the 2.4 gigahertz plan. Now, here we only have 3 channels to work with. I drew the circles bigger because they're going to be, the signal is going to propagate further just by, even if they were at the same power level. And you'll notice that if we go back and count the number of APs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 APs. Now here we have 1, 2, 3, 4, 5, 6, 7. So we have the same 12 APs. I didn't remove any APs, obviously. Well, maybe not so obvious, but I just turned off some of the radios. Why? Because you're not going to do yourself any good by having 2 or 3 APs operating on channel 1 in the same vicinity. You're not going to gain any more capacity doing that. So you would gain capacity in terms of the number of associations that you could support in 2.4, but here we're not really trying to do that. We're just trying to get the most out of 2.4. We're not really factoring in 2.4 in a design, but we don't want to shoot ourselves in the foot in 2.4. So we just decommissioned some of the 2.4 gig radios, and so that way they're not creating self-induced co-channel interference. All right, and summary. For the whole deck, we have a little bit of summary here. So wireless LANs, again, should be designed for capacity. Classroom use cases can require high capacity, as we saw here. It's a pretty high capacity with a 5 meg SLA for 30 devices concurrently. Wave 2 APs are here. The C120 is available. It will be available, I think the GA is scheduled for late May, the last I've heard. And it's in beta now. And then Wave 2 clients are here. Again, I just put up a subset of the clients that I'm aware of. There are a lot more clients that I'm actually aware of, and also that I'm sure there are lots of clients that I'm not aware of yet that are Wave 2. The Mojo networks, I say it's a true one, Wave 2, because of the fact it's up to 4 spatial stream multis and MIMO and the 160 support. Not all Wave 2 APs or APs that are marketed Wave 2 can say that. And then Wave 2 solution scales higher than Wave 1. Why? Because when you can talk up to 4 clients simultaneously instead of talking to one, then the other, with all the back off and the weights in between and the inefficiency of the single user MIMO, you get basically you can mitigate a lot of the loss due to contention, and in fact even improve on the single client throughput. I was in a webinar. I don't have the slide here, but it was a webinar that Qualcomm. We actually that webinar is available to you as well, and it was one that we had Qualcomm and we did a joint webinar where their testing showed 2.6 gain in aggregate or in performance with multi-user MIMO 1x1 clients versus single-user MIMO 1x1 clients. That's very, very exciting, and because what it means is you can build your networks with much fewer APs, so it's going to lower your total cost of ownership, not just for the AP, but all the other expenses like the cable runs and the labor to pull the cable out there, especially for greenfield deployments. So really, it's very, very exciting time for Wi-Fi. All right, now coming up, upcoming webinars. So we did the design best practices today. Next one will be, I think it's in 2 weeks' time, but Eric, correct me if I'm wrong. It's the deployment best practices. So we have a design, but now what are we going to do? Both on the wireless LAN side, the network services side, I should say, and also on the switching side. What are the things we want to make sure we keep in mind so that the deployment goes well? And then finally, we'll look at network management, and that'll include things like network, optimization and trend analysis and optimization, and also troubleshooting. A little bit about troubleshooting, and that would be for the 3-part series. Now we're going to open it up to questions, and let me take a look here. All right, so we have First question is, what do you recommend for the 2.4 gig radios or 11 AC solution? Yeah, and maybe you asked that one prior to me getting, that was one that we had covered where I showed you we decommissioned some of those 2.4 gig radios. That's because, again, we don't want to create self-induced co-channel interference. Co-channel interference is bad. It can really harm performance. So we don't want to have two APs on the same channel in the same vicinity. Yeah, enough about that. Will 11N clients benefit from 11AC APs? Well, yes, in a way. First of all, the 11AC APs have better CPUs. They have better radios, and they have typically better antennas, more memory. So all of those characters or features usually mean better performance for 11N clients as well, for all clients. But also because 11AC APs, because if the greater the ratio of wave 2 clients or even wave 1 clients, that means that you're going to be able to get clients, transmissions on and off the air quicker, which means more time for legacy clients or for 11N clients. So all clients are going to benefit with the the increased speeds, especially if there are a lot of wave 2 clients in the area, because those conversations will happen faster with the multis and MIMO, and that means more airtime for 11N clients. Is there a good use case in education for 160 megahertz? Well, I would say if you look at any time you have a really high throughput requirement and you want to minimize the number of APs that you're going to deploy, and it's a moderate to low density deployment, right? And you have spectrum available, then you should consider 160 megahertz. Would you do it in classrooms? No, you wouldn't do it in classrooms. Would you do it in an auditorium with high density? No, you wouldn't. But if you had some edge use case where it was really high throughput was required, but you didn't want to deploy 3 APs out there or 2 APs out there, and it was not high density, and it was an area where there wasn't a lot of other interference, you had a lot of capacity, a lot of spectrum availability, then you could consider a 160 megahertz channel. Again, your clients would have to be wave 2 to take advantage of that. Will wave 1 client support MU-MIMO with the software update? Not real wave 1 clients, but there are some clients out there that are actually wave 2 that may not have support for MU-MIMO yet. So in other words, they have this MU-MIMO it's wave 2 hardware, but certain features have not been enabled. Then they can, because there are some clients out there that have wave 2 client, but if you sniff them, they don't show as having beamforming support because they haven't had that capability turned on. So it really depends. Some clients will, you may not realize it, but they are wave 2 capable. Does your 120 support link aggregation? Yes. And when you'd want to use link aggregation is probably in combination with 160 megahertz. So if you had that edge use case where you have an AP and 160 megahertz, you could oversubscribe a 1 gig uplink. So we do support link aggregation between the 2 Ethernet ports. So that I think that may be it for questions, unless yeah, I think that's it for questions for now.
I don't see any more, but we'll give it another minute to come in, and I'll just review that final portion of the slide here. And wanted everyone to also draw your attention to the chat window. I've put the link for the next parts in this series for the Campus Design Guide, parts 2 and 3. So if you're interested in joining those, please, you can join through that registration link. And then also wanted to review how to receive your free access point. So for all of those on the webinar today who have not already received a free access point and are not one of our current valued resellers or distributors and partners, you are eligible. So you can contact us if you have any questions at myrep@mojonetworks.com, which you can see here on this Q&A screen. In addition, we'll be reaching out to confirm your shipping details as to where to send the free access point. So your Mojo sales rep will be reaching out to you today to confirm those. And again, if you have any questions, you can feel free to reach out to us at that time through that email address.